Welcome back, and this is going to be part 3 from the Poisson lesson. So, um, again, there's just going to be a little twist here. This doesn't crop up maybe too much, and because of technology, we've done away with it to a certain extent, but it can happen, okay? Because calculators have certain limitations on them. So here we go. And this happens when it's really a binomial situation. So we have got a fixed population n here. And when that happens, combined with a very small probability that something will happen. So this is really binomial because we have a fixed population n and we've got a probability. Right. Okay. But the problem is it's a large population. Right. Okay. So what we're going to do here is we're going to we've got a fix here. We're going to use an approximation to the binomial distribution and turn it into a Poisson distribution. So we're going to find a mean for the Poisson. So what we do here is we take the large population value n and the small probability value p, and like we're saying, it is binomial. So how are we going to get the mean mu? Well, we're going to do the following. Our mean in terms of Poisson, we take the n and p from binomial and just multiply them together. Okay. How do I know that? Well, somebody told somebody who told somebody who told me, and I'm telling you. Okay. It just makes things a little bit easier. So we're just going to go for an example here. Getting all sciencey here. So if somebody's given an injection of a serum, okay, the probability that they suffer a bad reaction is 0.001. That's pretty small. What's that, 1 in 1,000? Well, might not be small for that one person in 1,000, but anyway, for us in this problem, we're going to say that's small. Right, so we're going to work out the mean number. We're going to turn it into Poisson. So what's mean number? That people will suffer a bad reaction out of 2,000 individuals. So we've got a probability of 0.001, okay, p, and we've got our n, we've got our total, which is presumably large, 2,000. That's binomial. Let's turn it into Poisson. Right, so they're asking for the mean. There's my probability, 0.001. There's my total n, 2,000. Let's go and get mean. So we're going to use n times p, as we saw previously. N is 2,000, p is 0.001. I'm going to fire them in and give you a nice answer there. Okay, so our mean is 2. That looks okay. Right, so have we got other parts of the question now that we've kind of converted it to Poisson, so it's more manageable. Right, okay. Looks like we're going to get a question here. So we're going to determine the probability. Okay, what is probability? Exactly 3 will suffer a bad reaction. And part B, more than 2 will suffer a bad reaction. Right, okay, parts A and part B, exactly 3, we like those questions, one calculation, more than, well, you know, it's not just going to be one calculation, so more than and less than, there'll be multiple calculations, okay, multiple probabilities, and we'll see how we get on. Right. Oh yeah, parts A and B, they all relate to the 2,000 individuals. Okay. that have had this serum injected into them. Right, so for the first one, the exactly part, exactly 3 will suffer a badge reaction, but we did see that the mean, it was 2. Right, just going back to just so that you're aware where I got those values. Mean is 2 for Poisson, x is 3, exactly 3. There you go, there's your formula. Put your numbers in. Oh, I bracketed at the top this time. That's good practice. Okay, before I divide by 3 factorial. Fire that in. Our answer should come out between 0 and 1 again, because we're dealing with probabilities. It does indeed. 0.18045. Again, I'm always approximating them a little bit further just to give me a handle on the number. 18%, or I could have said 0.2, which would have been 20%. Just depends what we need this number for, because we're conveying information to people. Right, so we're saying here approximately 18% of 2,000 individuals will have an adverse reaction to the serum, whatever it is, the wonder serum. Right, okay, so that was part A. Again, exactly one calculation, and then I've just made a little comment at the end. I'm thinking 18%, that's quite a lot. Just looking at it again, that's a fifth. Need to look at those numbers again. Right, okay. Just remember, everything here is entirely fictitious. No individual was hurt in the process of making up this question and working through it. Okay, are we going to go for part B? Right, part B, the mean's going to stay the same. But we said it was greater than 2. So greater than 2, what does that mean? Well, greater than 2 does not include 2. Right, so we need to be careful here. So bigger than, greater than 2. First one would be 3, 4, 5, 6, 7. Okay. And have we got an upper limit here? Dot, dot, dot. Well, there was 2,000 individuals. So we do have an upper limit. But that's a lot of calculations. And don't forget, the plus, dot, 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 up to the plus. That's 8 all the way to 1998. Right? So we've got a lot of probabilities here. And from previous video, it looks like we're going to be looking at the complement rule here. So p greater than 2, we're just going to look at 1 minus p less than or equal to 2. Whatever number is the probability number, like 2, it's going to appear in both brackets. So, and it's usually always a greater than in the first bracket, but it doesn't have to be. But they'll be pointing in the opposite directions, the arrows. Okay? They'll be pointing in opposite directions. One of them will include the equals part, so that when you stick them together, the equals part's like a zip, and it zips the two wee arrows together. That'll give you your 1. So we're going to look at p less than or equal to 2. So less than or equal to 2, what does that include? 0, 1 and 2. So we've only got 3 probabilities that we have to calculate here. So that's good for us. So what I think I'm going to do here, I'm going to take the rectangular bracket there with the 3 probabilities. I'm going to calculate them on their own, and I'll bring it back to this page. So there you go. There you go. I've got my means 2 and my 3 x values of 0, 1 and 2. Okay, so I'll put them there. You can see your 3 probabilities. Okay, so I'm putting them into my Poisson formula. Okay, so one at a time here. Yep. And notice that they're very similar. You can see that the mean value of 2, it always appears in the top line. Okay. And that means it has the 3 powers of 0, 1 and 2 as we go down. And the factorials parts, that's your x values of 0 factorial, 1 factorial, and 2 factorial. So I'm going to go and put them into my calculator and just decimalize them. Okay, so let's see. So there you go. So that's my three probabilities. I'm going to decimalize them one at a time. Probability of 0, probability of 1, probability of 2. Don't worry, I've not made a mistake there. They do come up with the same answer there, right? And I'll let you go and look at the bare calculations to see why. In fact, let's go back and have a wee look. See if you're looking. Right, let's see if I can do this. And this is just for probably my interest more than yours. Right, I'm just going to treat that here. That's 2 to the 1 divided by 1 factorial. And 2 to the 1 divided by 1 factorial is actually 2. Okay. And the other one, 2 squared. So we're forgetting about the e part here. And I wish people wouldn't stop beeping me in that Teams. So 2 squared, I'm just going to show you this. 2 squared is actually 4. And downstairs, 2 factorials 2 times 1, which is just 2. And 4 divided by 2 is equal to 2. So for both of these, highlighted parts come out to a value of 2. And the 2's are multiplying that part. So 2 times e to the negative 2 and 2 times e to the negative 2, it's going to come out as the same answer. Right, it's just in case you thought you'd made a mistake in your calculator. Right, sorry for doing that to you, but it's good to be aware of these things. Right, okay, let's add them together and hopefully our answer will be between 0 and 1, because we're dealing with probabilities here. There you go, it's between 0 and 1, okay. 67, 688, am I going to round this again? I don't know. Oh, so that was the part in the bracket there, right? That was my P0, P1, P2, so I'm going to bring that back, okay? So fire that answer into the rectangular bracket and maybe get rid of the bracket. Yep. So probability greater than 2 is going to be 1 minus the sum of those 3 individuals, okay? So that comes out 0.32332, just a little bit less than a third, if you just think, because third bit 0.33333. Right. But the thing is, that was a probability of 3, 4, 5, 6, 7, 8, 9, all the way up to 2000, having an adverse reaction. So, I didn't even make a statement there. Maybe the dinner bell had rung there. So the statement I would make here, that the probability of 2, or of more than 2 suffering an adverse reaction to the serum would be, come on, 0.32332, or you could have rounded that up to 32%. Okay, so, but I did want to show you that was an example when n, the total, a fixed total here, is very large with a very small probability p, which is really binomial, we can turn that into Poisson. So see on the Poisson um, notes and exercises attached. I put that right at the end. I think I probably dedicated about 7 pages to it. But I said I didn't give you an exercise because of the advancement of the technology of calculators. They can usually do most of them. So if you think it's a binomial question, go for it. But if not, I did think it was necessary to show you that. Okay, so um, that looks like that's my third and final video extracted from the Poisson lesson. So we'll probably hear from me next, maybe in a normal distribution lesson. Right, bye folks.